Welcome to this explainer on modern cloud and infrastructure foundations. Today, we're talking about a massive, fundamental shift in how the digital world actually operates. Because let's face it, success in today's cloud landscape requires way more than just provisioning a couple of servers and crossing your fingers. It demands building a true, indestructible digital fortress. And to do that, we rely heavily on the well-architected framework. This means we're designing cloud systems using strict best practices for security, reliability, performance efficiency, cost optimization, and operational excellence. We are completely leaving behind those fragile manual setups to engineer systems that are highly repeatable, heavily protected, incredibly resilient, and absolutely ready to scale right alongside your business.
To really appreciate where we're going, we kind of have to look at where we've been. The old world of infrastructure involved a ton of risky manual intervention. You'd literally have engineers clicking through endless dashboards, hoping they didn't miss a setting. Moving to this new world, where absolutely everything is defined in code files, well, it changes the game entirely. This is where robust governance comes into play. By stepping away from those manual clicks, organizations can suddenly enforce critical policies, standards, and compliance right from day one. Things like identity management, access control, tagging, and risk management become deeply embedded in your process, helping you stay strictly controlled and fundamentally secure.
So here is our blueprint for today. We're going to cover 1. Infrastructure as code, 2. Security-first design, 3. Designing for resilience, 4. Scalability, and 5. Real business impact. Let's get right to it. Starting with Section 1, Infrastructure as Code. This is literally the foundation of everything we're building. Just to make sure we're all on the same page, Infrastructure as Code, or IAC, is the practice of managing and provisioning your tech stack using code instead of manual configuration. So instead of navigating a clunky web interface and just praying the right checkboxes are ticked, your engineers actually write clean, reviewable code to deploy entire environments with absolute precision. What's truly revolutionary here is the sheer scale of control you get. Using a leading multi-cloud tool like Terraform, it is possible to instantly provision incredibly diverse resources all at the exact same time. We're talking virtual networks, subnets, compute instances, load balancers, databases, security groups, and massive storage systems. You just write the configuration file, and the automation engine translates that into functioning reality, even across multiple cloud providers.
The really crucial point here is that code equals absolute consistency. Beyond just being super efficient, version control provides an immutable audit trail. This is a massive leap forward for governance. It gives you the superpower to track every single change, maintain tight compliance, seamlessly manage your risk, and collaborate safely across teams. And the best part? You can rebuild your entire infrastructure instantly if disaster strikes. If something breaks, you don't panic. You literally just execute the code again.
But hey, before we get too excited about all this deployment speed, we need to remember this fundamental rule. Automation without security can automate mistakes faster. If you automate a flawed, unsecured system, you're not helping yourself. You are literally just scaling your vulnerabilities at lightning speed. Which brings us to Section 2, Security-First Design. These are the load-bearing walls of our fortress. Now this is where DevSecOps becomes our absolute main priority. Security must never, ever be bolted on at the end as some sort of afterthought. It has to be integrated into every single stage of development and operations. Building these load-bearing walls means implementing secure coding practices from the very start. It requires automated security testing and continuous vulnerability scanning embedded deep within your CI/CD pipelines. Core principles like least privilege access ensure that users and systems only get the exact permissions they truly need. And when you combine that with rigorous network segmentation, secure firewalls, and deep encryption for data at rest and in transit, you create an incredibly formidable defense. But a truly comprehensive DevSecOps strategy goes even further into your daily operations. You absolutely must utilize dedicated secrets management to ensure passwords and API keys are never hard-coded into your environments. Container and infrastructure security has to be continuously verified. And remember, visibility is security, right? So centralized logging and continuous monitoring are absolutely necessary to enable active threat detection. Having compliance automation and robust backup planning in place means you aren't living in some fantasy world where attacks never happen. Instead, you're fully equipped for incredibly fast response to incidents and rapid recovery. Let's move on to Section 3, Designing for Resilience. This is all about structural support. So now that we're secure, we look to resilience engineering.
To survive massive physical failures, we rely heavily on the availability zone, or AZ. Basically, this is a physically separate data center located within a specific cloud region, completely equipped with its own independent power, cooling, and network infrastructure. Resilience engineering is fundamentally about how systems manage to stay available during major failures. By leveraging multi-AZ architectures, resources like your web servers and database replication are spread intelligently across these distinct physical locations. Let's say a catastrophic event takes down Zone A. No problem. The architecture enables automated failover, and Zone B just seamlessly takes over the traffic. When you pair this with continuous monitoring and automated disaster recovery protocols, it drastically reduces your single points of failure, ensures continuous improvement, and genuinely pushes the organization toward that ultimate goal of zero downtime. Okay, Section 4, Scalability. Time for expansion and growth. With strong security and unshakable resilience totally established, we can confidently turn our attention to handling massive growth without the whole system collapsing. As application traffic spikes, compute instances must auto-scale, traffic needs intelligent load balancing, and storage has to expand automatically. But here's the catch. Scaling your infrastructure also means scaling your costs. That is exactly why FinOps is vital here. FinOps is how organizations manage cloud costs responsibly. Through deep visibility, rigorous usage tracking, intelligent budgeting, and right-sizing resources, teams maintain shared accountability. FinOps basically ensures you are maximizing your actual business value during an expansion, rather than just scaling your budget completely out of control. However, never forget this fundamental truth of cloud architecture. Growth without security simply creates exposure. As your systems scale dynamically across the globe, your access controls, centralized logs, and continuous monitoring must expand perfectly right alongside them. Growth should always strengthen a business, never weaken its defenses. Which leads us to Section 5, Real Business Impact. This is the masterpiece we've been building toward. Let's zoom out to the executive level for a second. Why does all this highly technical architecture actually matter? Because building modern infrastructure is fundamentally business critical. A well-architected cloud directly translates to massively reduced downtime and a far better security posture. Thanks to proper FinOps practices, you achieve significantly lower cloud waste. And with DevSecOps and governments driving your automation, you secure faster delivery with incredibly tight control. This gives you a much stronger operational maturity that fiercely protects and builds higher customer trust. Ultimately, modern cloud environments are built through the proven principles of the well-architected framework. DevSecOps gives you unparalleled trust. FinOps ensures vital financial responsibility. Resiliency engineering provides unshakable stability. And strict governance keeps you in total control. By beautifully blending these elements, businesses can finally move fast with absolute unwavering confidence. I really hope this explainer leaves you eager to dig deeper into the actual mechanics of these cloud foundations. So, I have to ask, are you ready to stop relying on manual configuration and start engineering an infrastructure that can withstand absolutely anything the digital world throws at it? If you want to master these concepts through practical, hands-on projects, real-world scenarios, and guided deep dive cloud training, I highly encourage you to continue your journey at Oz University. It's time to learn by doing, practice consistently, and build true expertise. Belong, learn, build. Thanks so much for joining me today, and I will see you next time.